Okay, so today we're talking about similar polygons, whereas yesterday we were talking about just being proportional, pretty much. So figures that are similar have the same shape, but not necessarily the same size. So they have to have the same shape, but they can be the same size, or they can have different sizes, okay? Notice the symbol here. It's very close to a congruence, except it does not have the equal, so they're not always equal, okay? Triangle 1 is similar to triangle 2. That is because they have the same shape, but a different size. Are angle 1 and angle 3 similar? No, why not? They have a different shape. Okay? So, we have this theorem, or this definition of similar polygons, and it says two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. Now, if you remember, we had if and only if before. That means it's a biconditional statement, which means it's true both forward and backwards. Okay? So, what that is telling me is if I have a similar polygon, then I get these things. I get that the corresponding angles are congruent, and I also get that the corresponding side lengths are proportional. Backwards, if I have that my angles are congruent and my corresponding side lengths are proportional, then I get that my two figures are similar. Okay? So, in example 1, it says identify the pairs of congruent angles and corresponding sides. Now, there's something that's important to me that I actually need to pay attention to, and that is this right here. Just when we had congruent triangles, it mattered what order they were written in. It matters with similar as well. I know that M has to correspond to T, so M and T. I also know that N is going to correspond to Q, and P is going to correspond to R. Now, this one, it's not necessarily that important because I have a nice right angle. I also have this angle marked. That's not always the case. They don't always give you that much, but they generally will give you this otherwise, and it's important to know how to use that. Okay? So, first I want to name my congruent angles. My congruent angles, I have angle M is congruent to angle T. I have angle N is congruent to angle Q. And I have angle P is congruent to angle R. Okay? Now I also need to have my corresponding sides. Now my corresponding sides from above have to be proportional. And if they're going to be proportional, that means they're all going to simplify to the same exact ratio. So I'm going to just pick a side. I'm going to do MN first. MN is corresponding to what on this other triangle? Well, that's where my markings come in handy. I went from green to blue, so I must do the same when I am on this one. So I'm going to go from T to Q. So MN I know is 2, TQ is 1. Can that be simplified? No, so I'm done. My next I'm going to do is MP. So I went M to P, which went green to pink. So my corresponding side on my other triangle is TR, because it's green to pink. So MP is 2.2. TR is 1.1. Now, I need to make sure that this simplifies to the same thing. And if you don't know, you can use your calculator and just do 2.2 divide by 1.1. Go math, which is right here, math, frac, enter, and enter again, and I get 2. Well, I don't want just 2. It has to be a fraction, so it's 2 over 1. Those match, so I'm good. Now I have another one to check. The only other side I haven't done is NP, and the corresponding side to NP is QR. So NP is 1 over QR. I don't know it. So what am I going to need to do? To make sure they're proportional, I have to have it, so I'm going to have to find it. So I'm going to come over here and I'm going to actually find it. Well, how am I going to get to find it? I have a right triangle. What can I do with right triangles? Pythagorean theorem. Remember, always across from the right angle is always A, B, or C. C. I'm going to call this A and this B. So I know I have C squared is equal to A squared plus B squared. So if I substitute in, I'm going to have 1.1 squared is equal to 1 squared plus my B squared. So if I do 1.1 squared, I get 1.21 is equal to 1 squared, which is 1, plus B squared. And now I'm going to subtract. So I have 0.21 is equal to B squared, but I don't want B squared, I want just B, so I have to take the square root. So in my calculator, the square root of 0.21, I get this. I'm going to round to the nearest tenth. So the tenths place is where the 4 is. The 5 is telling my 4 to go up. So I get 0.5 is equal to B. Now I'm going to plug that in right here. But remember, I need to have this simplified. So in my calculator, I'm going to do 1 divided by 0.5, math, frac, enter, and I get 2, which means it's 2 over 1. So are my angles congruent? Yes. Are my corresponding sides proportional? Yes, because they all simplify to the same thing. Okay? All right. A similarity ratio or scale factor is the ratio of the lengths of the corresponding sides of two similar polygons. So it's the ratio of the lengths of my corresponding sides of two similar polygons. So here I have two polygons, correct? They're closed figures. So the similarity ratio of triangle ABC, which is this one, to triangle DEF, which is this one, is 3 over 6. Now, I know that this is a ratio because it has the word 2. Excuse me. Now, how do I know whether the 3 or the 6 is on top? Whatever is written first goes on the top. Whatever is written second goes on the bottom. So I pick a side off of ABC, doesn't matter what side, it's 3 over my corresponding piece on the other, doesn't matter because they're all the same, is 6. So 3 over 6, and I have to simplify, so it's 1/2. So if I want the similarity ratio of triangle DEF, 2, there's my key word again that I know it's a ratio. Triangle ABC, whatever is first goes on top, whatever is second goes on the bottom. So now it's flipped, it's 6 over 3, which simplifies to 2 over 1. Do I have to leave the 2 over the 1? Yes, because it's a ratio. I cannot just say 2. It has to stay as a ratio, comparing two things. 1, 2. So it has to stay 2 over 1. So in example 2, it says, write the scale factor of quadrilateral ABCD to quadrilateral EFGH. Okay, that means whatever's in front of the word 2 goes on the top. Whatever's behind the word 2 goes on the bottom. So I know I'm going to pick a side on ABCD. I have 4 different sides. Does it matter which side I use? No. Sometimes these are turned different directions, so you do need to make sure that you are using corresponding pieces, and you can do that by checking where you're looking in relation with your angle markings. I'm going to choose this side, so I have 1 angle marking to 4, so I'm going to have 10 over because I picked AD. I have to match that with, here's AD, so I have to match that with EH, which is here, or I can also tell because of my angle markings, 1 and 4. So 10 over 5, can I leave it like that? No, I have to simplify, which would be 10 divided by 5 is 2, but that's not a ratio, so it has to be 2 over 1. Now, example 3 says, what is the ratio of the perimeters? So I want the ratio, but now I want the perimeters. How do you find the perimeters? Add all the sides. So my perimeter of A, B, C, D, I'm going to add all my sides. So I'm going to add 10 plus 8 plus 6 plus 5, which gives me 29. And then I'm going to say the perimeter of quadrilateral EFGH is going to be 5 plus 4 plus 3 plus 2.5, which gives me 14.5. Now, I have not made a ratio yet. A ratio is a comparison of two things, and I'm going in the same order because the example didn't tell me what other order. So I'm going to say ABCD is on top, and this one is on bottom. So I'm going to have 29 over 14.5. So I'm going to get my calculator, and I'm going to do 29 divided by 14.5, math, frac, enter, and I get 2. Well, that's not a ratio because I need it as a fraction, so it has to be 2 over 1. And there's my ratio, my perimeters. So it says, notice, the ratio of the blank is the same as the blank blank. The ratio of the perimeters is the same as the scale factor. This will always happen. This is important to you. The ratio of the perimeter is the exact same as the scale factor. Okay? I also already told you this, but it's important that you need to know. When you write a similarity statement, it's like writing a congruent statement. Be sure to list corresponding vertices in the same order. Okay? So, that's when we went back over here on the front. This matters. M had to go with T. N with Q. P with R. That's what we're talking about. That does matter. Okay? All right, example 4 says, determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Okay. If they are similar, I need to determine that. To be able to determine whether something is similar, there are a couple of things I need to check. I need to check, 1, that the corresponding angles are what? Congruent. And 2, I need to check that the corresponding sides are proportional. Those are the two things that I have to check. I can't just do one of them. I have to do both of them. Okay? So we have rectangles ABCD and EFGH. So, if I know I have rectangles, what does that mean by definition? They have 4 right angles. So these are all right angles. Okay? So, that means angle A is going to be congruent to angle E. That means that angle B is going to be congruent to angle F. Angle C is going to be congruent to angle G. And angle D is congruent to angle H. Do I have to write that? Yes. Otherwise, you're not going to be able to tell me that the corresponding angles are congruent. Okay, now we also have to check my corresponding sides, and my corresponding sides need to be what? Proportional. All right, now, am I going to have to check all 4 sides? Maybe. Maybe not. I'm going with no. And the reason is I will need to check 2 sides because it's a rectangle. And what do we know about rectangles? Opposite sides are congruent. Well, if I check the 2 that are not the same, then my other 2 should match up to the opposite sides. Okay? If it were just a quadrilateral, can I just check 2 sides? No, because a quadrilateral is just a four-sided figure. I would have to check all four sides then. Okay, so the only reason I'm only having to check two now is because it's a rectangle. So if I check my corresponding sides, I'm going to go with BA is corresponding to what? So here is BA. It is corresponding to FE. So BA has a length of 6. FE has a length of 4. And can I leave it like that? No, because it's not simplified. 6/4 is reduced to 3/2. Okay, now, would I want to check CD and GH? No, because that's going to be congruent to BA and FE. So I also need to check BC, which is corresponding to FG. So BC has a length of 9. FG has a length of 6. If I need to simplify that, do so, which I do. I can divide each by 3, so that's going to give me 3/2. Are these two matching? Yes. So are these two similar polygons? Yes. Now I have to write, yes, they're polygons. I'm going to say, since corresponding angles congruent and corresponding sides proportional with scale factor of 3/2. Therefore, remember the 3 dots kind of in a triangle means therefore, rectangle ABCD is similar to, notice there's no equal sign, rectangle EFGH. Now some of you aren't going to want to do all this, and I'm sorry, but this is no different than when we had to prove other things. You're going to have to show me all the steps, okay? All right, example 5. Determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. All right, so if I look at this one, QPR, to determine if it's similar, I have to check, 1, corresponding angles are what? Congruent. And 2, corresponding sides are proportional. Okay, so my guess is that angles are always the easiest. So let's check. I know that these two sides are congruent, correct? What does that mean to me? That the opposite angles from them are congruent. So this is congruent to this. Well, can I figure out what that is? Yes, I can do 180 minus 36, and then do what? Divide that in half because these both have to be the same. So this is 72 degrees. This is 72 degrees. Now what? I automatically know that these two triangles are not similar. Why? Because none of my angles in this one, 36, 72, 72, matches up to an angle of 62. So I'm going to say no, since corresponding angles are not congruent, therefore triangle PQR is not similar, so it's similar with the slash through it, triangle STW. All right, so a helpful hint. When you work with proportions, be sure the ratios compare corresponding measures. Okay, so in example 6, it says find the length of the model to the nearest tenth of a centimeter. So if I'm looking at this, I have my racing car and I have my model. Okay, so I have my racing car and I have my model. All right, so this side, or the back of my car, it's 1.8 meters over its corresponding piece on my model, the back of the car, is 6.3 centimeters. That is going to have to equal, we're setting up our proportion like yesterday, the length of my racing car, 5 meters. Is that going to go on the top or the bottom? The top, because that's where I have my racing car, 5 meters, over the length of my model, which is x. To solve, I'm doing my cross products. So 6.3 times 5 has to equal 1.8x. So when I do that, 6.3 times 5 gives me 31.5 is equal to 1.8x. So I'm going to divide by my 1.8, and I get x is equal to 17.5. Now I need to figure out, is this centimeters or is this meters? Well, my model is where my x is, and that is in centimeters. All right? And that is it for today. You do need to finish your homework, and it is due tomorrow. Thanks!